Okay, I'll be discussing linear and angular momentum and how they apply to Bessler's will. And we have Newton's laws of motion, courtesy of NASA. An object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line, unless acted by an unbalanced force. With Bessler's will, this disk right here, which there's two of them, one on each side, and these levers will rotate this disc. When that disc rotates in a clockwise direction, it lifts this weight outward. Okay, basically how this is going to work, there are two sides, and this will ride on here. It'll have a bar going across, so that way it'll be inside, but then as the wheel rotates, it lifts the arm up. And so then that is an unbalanced force right here. It's not a part of the wheel. It does not rotate or move. It is on the stand. And so when it's on the stand, the lever right here has resistance and uses leverage to rotate this. So then when the weight is increasing in velocity because of the downward force of gravity, that is linear momentum. I'm calling it angular momentum because when it is lifted, coming towards bottom center, it's in a balanced position. Here it's underbalanced because of that disc will cause the hoist to lift it. That's what hoists do. And so I'm saying that once it moves closer to the axle until it is its furthest distance from the axle, it can be both linear and angular momentum, because this path right here is about what it will follow, and it will be dropping while it's moving further from the axle of the wheel. And in that instance, it's both angular momentum because its rate distance from the axle is changing, but then once it's past the center line, once it's on this side, gravity will start acting on it, so that will be linear force, which is a force acting straight down to accelerate it. Mass times velocity equals, force or momentum. It can be either way. F equals ma is force, and P equals mv is mass times velocity equals momentum. And then with angular momentum, this is hyperphysics, and it tells us how to quantify centripetal force